Line 22f1fa19c3k11 Tetrahedron Electrolytic Reactions Isomers Double Bonds UFO 5G Wow Seti. So there's the alien radio signal. There's the answer to it. So September 13, 2012, 3:40 p.m. Continue from the previous video. Tetrahedral molecular geometry. This is a graph of it. See the three H's and the C in the middle, which would be the core. The tetrahedral molecule methane CH4. Quote, in a tetrahedral molecular geometry, a central atom is located at the center with four substituents that are located at the corners of this tetrahedron. The bond angles are this formula here. When all four substituents are the same as in CH4, this molecular geometry is common throughout the first half of the periodic table. The perfectly symmetrical tetrahedron belongs to point group TD, but most tetrahedral molecules are not of such high symmetry. Tetrahedral molecules can be chiral. Quote, transition metal chemistry. Again, this is from Wiki. Again, the geometry is widespread, particularly so for complexes where the metal has DO or D10 configuration. Illustrative examples include triphenylphosphine, palladium, zero nickel carbonyl, and titanium tetrachloride. Many complexes with incompletely filled D shells are often tetrahedral. Example, the tetrahalides of iron 2, cobalt 2, and nickel 2. So here's some more graphs here. Okay, it says cyclohexene is an acylic compound with a double bond. Cyclohexene is an acylic compound with a double bond. So both of them have the same word. Quote from Wiki. In organic chemistry, an electrocyclic reaction is a type of persulate rearrangement where the net result is one pi bond being converted to one sigma bond, or vice versa. So it's being converted from one pi bond to a sigma bond. These reactions are usually categorized by the following criteria. Reactions can be either photochemical or thermal. Reactions can either be ring opening or ring closing, electrocyclization. Depending on the type of reaction, photochemical or thermal, and the number of pi electrons, the reaction can happen through either a con-rotary and dis-rotary mechanism. The type of rotation, again, keyword is rotation here. The type of rotation determines whether the cis or trans isomer of the product will be formed. So again, this will be used in the mathematical equations when you're looking at the core of the UFO. Obviously, this has something to do with it, okay? That's what the WOW videos are about building a UFO spaceship that can travel very, very, very fast. So August 14, 2012, the keyword is rotation, the outer shell of the UFO. How to get it to rotate around the middle cell comes to mind. Now take a look at this. This is where I think of the middle cell, and these are the 4 points around it. And again, it was like in a triangle, and it has spindles off of it, a circle. A great big circle, kind of like an oblong circle with a little circle in the middle. If you go back to the original, very first videos, 280 videos ago, you'll find it. Okay? So cis but 2E and E. And here's the next graph. Again, it changes a little bit. See that? It kind of flips. Goes down to the bottom. See that? So the only thing that flips is this one here. But 2E and E. So cis-trans isomerism. Quote from Wiki. In organic chemistry, cis-trans isomerism, also known as geometric isomer configuration isomerism, or EZ isomerism, is a form of stereoisomerism describing the orientation of functional groups within a molecule. Excuse me if I'm saying the words wrong, I apologize. In general, such isomers contain double bonds which cannot rotate, but they can also arise from ring structures when the rotation of the bonds is greatly restricted. That's where we have trouble, trying to get the rotation to keep going, and we have the barriers of molecules and dark matter slowing it down, right? Cis and trans isomers occur both in organic molecules and in inorganic or coordination complexes. The terms CIS and trans are from Latin, in which cis means on the same side and trans means on the other side or across. The term geometric isomerism is considered an obsolete synonym of cis-trans isomerism by IUPAC. It is sometimes used as a synonym for a general stereoisomerism, e.g. optical isomerism being called geometric isomerism. The correct term for non-optical stereoism is diastereoism. Yeah. Boy. It's amazing you guys know how to type this stuff without getting all the correction errors and stuff. Sorry. 14th August 2012 is when I was originally working on this, and today's September 13th is when I'm actually videotaping it. My thoughts. Keywords. Such isomers contain double bonds. Double bond stands out in nuclear fusion formulas as well. So, again, nuclear fusion came up in lines either 17, 18, 19, 20, 21, or 22. We're in line 22 right now. So, it's sporadically in and out of the videos. And, of course, when we get to the end, we'll Google it and research it and see which ones it comes up with, and then put all those keywords together to see what we come up with. So, inorganic chemistry, quotes from Wiki. When the substituent groups are oriented in the same direction, the diastereometer is referred to as cis, whereas when the substituents are oriented in opposing directions, the diastereometer is referred to as trans. An example of a small hydrocarbon displaying cis-trans isomerism is 2-butane. Alicylic compounds can also display cis-trans isomerism. As an example of a geometric isomer due to a ring structure, consider 1,2-dichlorocyclohexene. So that's what it looks like. And there's the big words to go with it. Okay. So the keywords are higher melting points and temperature from the next quote from Wiki, okay? Trans isomers also tend to have lower densities than their cis counterparts. March observed that trans alkanes tend to have higher melting points and lower solubility in inert solvents, as trans alkenes in general are more symmetrical than cis alkenes. Vicinal coupling constants, and there's the term for it, measured by NMR spectroscopy, are larger for trans, and there's the range for it, and the range for isomers. Okay, so here's a graph I looked it up, and intensity arbitrary units. I just wanted to see what this looks like. What does that look like? It actually looks like the Higgs boson signal, doesn't it? The way it goes up and down again. I don't know if I've cross-referenced that or not, but I'm also working on the Higgs boson particle mass theory, and that's in the other videos that are on the Idea Girl Says YouTube channel. So binding energy and intensity. Okay, so there's your signals from C1s, XPS, and that's what comes up. So C1s, XPS spectra of a SWCN film exposed to the two cycles of hydrogenation and dehydrogenation. Clean SWCN film, hydrogenated CWCN film, SWCN annealed at 600 degrees, hydrogenated SWCN film, SW annealed at 600 degrees Celsius. It's interesting because when you did the Higgs signal, you had to force the two beams to go at a higher rate of speed and a higher temperature in order to produce your signal. And here this is producing a signal at 600 degrees. It is clear that the second hydrogenation led to the restoration of the shoulder that is due to the signal from CH bonded carbon atoms. So you have a signal from CH bonded carbon atoms that looks like your Higgs boson signal. Just an observation here. August 27th was when I was working on this particular data, and today is September 13th. My thoughts. Looking at the data above, this came to mind. It's from line 22, F1fa19c3k11. So this data, I did a cross-reference. Hydrogen storage, Li-doped carbon nanotubes, 5G Wow Seti. So that's the title of the video. Started the rest of the research on another day, as you can see, September 13th. My thoughts. Looking at the data, these are the keywords. Formula. Tetrahedral plus atom plus tetrahedron plus bond angles plus symmetrical plus point group TD plus chiral plus transition metal plus iron plus cobalt plus nickel plus cyclohexene plus double bond plus electrocyclic plus reaction plus pi bond plus sigma bond plus thermal plus pi electrons plus mechanism plus rotation plus isomer plus formed plus outer shell UFO plus matrix rotation plus middle cell plus cis butene, almost like butene there, plus ring structure plus complexes plus geometric isomerism plus IUPAC, International Union of Pure and Applied Chemistry, plus LSF compounds plus isomerism plus dichlorocyclohexane plus higher melting points plus temperature plus vicinal coupling constants plus NNR spectroscopy plus XPS spectra plus SWCN film plus 2 cycles plus hydrogenation plus dehydrogenation plus restoration plus signal CH bonded carbon atoms. And again, I didn't compare it with the Higgs boson, but obviously that's what it reminds me of. Okay, so thank you for watching, and I have another video to film after this, and it's a continuation of this research. Okay, thank you for watching.